Hi everyone, this is our lesson on half-life, and by the end of this lesson you should be able to explain and calculate half-life of radioactive isotopes. So let's first define what half-life is, and it is the amount of time required for 1/2 of your sample of a radioisotope to decay. So we've got whatever radioisotope we're looking at, we want to know how much is left after 1/2 has decayed out. So in one half-life, half of your sample will decay into stable isotopes, whereas the other half will remain radioisotopes. And then these half-lives can vary from super quick to billions of years, depending on the radioisotope itself. So for instance, an example like iodine has a radioisotope that is actually used in like scans at the hospital that they inject into your bloodstream. It lasts about 30 minutes, 27 to 30 minutes. And then you have others, I'm pretty sure it's cesium something, one of the radioisotopes, and it's like 25,000 years. So it all depends on which radioisotope you're looking at the time. And something that's important to understand is we can change the chemical reaction rate of reactions, as we've learned earlier with temperature and concentration and pressure and things like that. If you change those in a nuclear reaction, that will not change the half-life. It is only dependent on the radioisotope you're looking at. It is a constant value. It will not change. And when you look at radioactive dating, also known as carbon dating, which I'm sure you've heard of, we look at an object or a fossil and we will measure the amount of carbon-14 left in that sample to the amount of carbon-14 in the atmosphere, and you can actually calculate back to where or when that fossil last existed or was last alive, as that breaks down after death. And then here's just a quick example just showing you what half-life looks like pictorially. So now that we know what half-life is, let's talk about calculating it. And we have two different methods to do this. Also, depending on when you watch this video, you may need to add this and write it into your notes. The first method is the arrow method, and we use this for really small number of half-lives that we've gone through or whole number half-lives. So it's very simple. For those of you who maybe struggle with math, this might be the way to do it. You're going to take your original amount of your sample and divide by 2 for as many half-lives as you have gone through. So if you've gone through 3 half-lives, you divide by 2 3 times on your answer. So for example, your original amount divided by 2, that's how much is left after 1 half-life. Divide that by 2, that's how much is left after 2 half-lives, and so on and so forth. But sometimes you might have to go through 27 half-lives. You're not going to want to do that. Or you're going to go through 2.78 half-lives, and you can't do the arrow method if it's not a whole number of half-lives. And that's when we pull in this calculation. And this is a good one to have in your notes. And actually, the little picture that's going to pop up in a second is going to show you what each of these variables stand for. So a to the t power, excuse me, that I have on the left here is just a on our example. That's your final amount. That's what you end up with. A naught, which is here, is your initial amount. If it's a percentage that you're looking at, so if I say the word percentage in the problem, then your original amount is 100. Otherwise, I'm going to give you an original amount, or you're calculating for it in grams, most likely. And this is going to be times 1/2. And I don't really like this part. I just usually do it to the nth, which, it's the same thing. So to find the n, you're going to take the time passed and divide it by your half-life that's given. And that's going to tell you the number of half-lives that you've gone through. So now let's look at an example together. So this says that we have an isotope that has a half-life of 6 hours. What percentage will be left after 24 hours? So we know we've got, let me underline this whole thing, half-life of 6 hours. How much is left after 24 hours? And that's what we're looking for. So now let's go into the problem. So remember, we have to find that exponent first, so that n. and that is time passed over your half-life. So if our time passed was 24 hours, our half-life is 6 hours. We're going to do 24 divided by 6. So we've gone through 4 half-lives. That's not many, and it's a whole number, so we can use the arrow method. Remember that percentage here that we circled means that our original amount is 100. So to do the arrow method, we're going to do 100, and then we're going to go and divide by 2. So after 1 half-life, we've got 50%. After 2 half-lives, we've got 25. After 3 half-lives, we've got 12.5. And after 4 half-lives, we have 6.25. And then we can also look at the calculation, which would be 100 times 1/2 to the 4th, and that will also give you 6.25. Please be very clear with this. If you remember your order of operations in math, you need to do this exponent part first because exponents come before multiplication. So do 1/2 to the 4th and then multiply it by your original amount. Do not do it in the order because it will then do 100 times 1/2, then put that to the 4th. We don't want that. So now that you've seen this, I want you guys to pause the video after I move all my little stuff here. Pause the video and try this example for me.